This video will go over the identity and inverse properties. For identity, the quantity does not change. It keeps its identity is the way that I think about it. In words, the identity property of multiplication states that multiplying 1 to any number does not change the value or identity of that number. Anytime you multiply by 1, nothing changes. The identity property of addition states that adding 0 to any number does not change the value or identity of that number. Here's a picture. Here's thing 1, and here's thing 1. Nothing's changed. So we either added 0 or we multiplied by 1, but regardless, nothing changed. Okay, here are some examples. Here's another picture, actually, of things. So here we have, if you think about these blocks, we think about these blocks as x's. So a rectangular block is x, and a shaded block is -1, a square, and then just an open square is +1. So 1, 2, 3, 4, 5. So this is 5x. Here we go. So 5x plus 0, these two cancel out, -1 plus 1 is 0, equals 5x. So nothing changes in the term that you add 0 to, you still end up with the same identity. 0 plus ab equals ab, 75 plus 0 equals 75, 1/2 plus 0 equals 1/2. And then here's a funky one, right? So this is an example where I feel like your brain would look at this and then think, oh, this is distributive, or oh, this is associative, just because you see these grouping symbols. But if you really look at this, you have 4 times the quantity x plus 6 plus 0. So you have this junk plus 0 is equal to the junk. If you have something plus 0 equal to that something, then you know it's the identity property of addition. All right, the identity property of multiplication is that you just take a group of something. So 5 times 1 is equal to 5. So it's really just one group. If you have one group of something, then you know that you're just going to end up with that something, right? So the picture here, we have the x blocks again. So we have 1, 2, 3, 4, and this is just in a group. So we have a group of 4. One group of 4 is equal to 4. And you might see this in other ways too. So whenever you reduce a fraction or you find equivalent fractions, you're actually using the identity property of multiplication. Because if I take 4 times 2 to get 8, and what you do in the numerator, you have to do in the denominator, because this concept here, 2 over 2 is just 1. So 4/7 times 1 is 8/14. And if you take 4 divided by 7 and you take 8 divided by 14, you're going to get the same numerical value in decimal form. So therefore, you're not changing the value of the fraction, you're just changing how it looks. And then sometimes when you're looking at the distributive property, then you can distribute 1. So 2 plus 1 times this quantity is just going to be, you do not add the 2 plus 1 ever, never, ever. So you do 2, keep the 2, and then you distribute the 1 in the parentheses, which just means you can drop it, because 1 times x is x and 1 times 6 is 6. The inverse. The inverse property, you have to remember that the opposites undo each other, okay? So what I mean by that is that if you're going to add a number plus its negative number plus its negative version, its inverse, its opposite, you're going to, okay, I'm going to add 5 and subtract 5. Okay, well, that's going to be 0. So you add 5 plus -5, and it's going to be 0. So you kind of undo the operation from each other. So you have the inverse property of addition states that the sum of any number and its opposite will always be 0. And when we say opposite, we mean opposite sign. The inverse property of multiplication states that the product of any number and its reciprocal, which is a multiplicative inverse, the inverse of multiplication, will always be 1. Here's a picture. Opposites, hot and cold. Okay, reciprocal is the, quote, upside down fraction, which I'm not going to refer to it as that. So the reciprocal of a over b is b over a. So just remember that. And also you have to remember the reciprocal of 10 is 1 over 10. The reciprocal of 75 is 1 over 75. The reciprocal of x is 1 over x. Keep that in mind. That's a tough thing to remember. Examples. So the inverse property of addition, so you have this person here, it's a goofball. So you have x plus -x equals 0. So the sum of x and the opposite of x is 0. So negative 2x plus 2x is 0. And when you do that, this is kind of like, should remind you of when you solve equations, right? So if you have a negative 2x and you add 2x on both sides, it, quote, goes away. Well, it's because you're using the inverse property of addition. 4 plus negative 4 is 0. If you have 3 positives and 3 negatives, they cancel out and they become 0. All right, the inverse property of multiplication. I think technically this guy should be like doing a handstand, but that's okay. So x times its reciprocal 1 over x is equal to 1. And the reason that is true here is an example. So 2/3 times 3 over 2. So 2 times 3 is 6. 3 times 2 is 6. These 2's cancel out, the 3's cancel out, and you get 6 over 6, which is just 1 whole. 5 times a fifth, you take 1/5 of 5, and you're going to get 1. So if you have like 5 pizzas and 5 people, everybody gets a fifth to share everything, right? So you take 5 times a fifth, everyone gets 1 pizza. And then here, this is like the last goofy example, is sometimes you might have a reciprocal happening where you have something left over, but you're still using the inverse property, because this is 5 over 2. So 5 divided by 2 times 2 is equal to 5. So this fraction means divide. When you divide by 2 and you multiply by 2, that it undoes the like division and multiplication cancel each other out. So here we start with 5. If you take 5 and then you divide it by 2, it's 2.5, and then when you multiply that by 2, you get back to 5. So we're just using the inverse property of multiplication here.